So let's get started. The first question is, do wind turbines produce much noise? Well, contrary to the popular belief, wind turbines are not noisy. They do produce a swish sound which can be heard by a listener standing close to the base of the turbine. To put this into perspective, your air conditioner noise level is about 50 decibel. A wind turbine that is 300 meters away produces noise that is only 43 decibels. It has to be remembered that turbines are located well away from population centers, both because of regulations and for their own effectiveness. I guarantee you will never hear a sound even if you drive past a large wind farm. This brings us to the second question: where is the wind industry heading? The wind industry has seen exponential growth in the last decade. The industry, having already plucked the low-hanging fruit of onshore winds, is now moving towards offshore wind energy resources. Floating wind turbines designs are being tested that can be installed in deep waters without the need of bottom-mounted towers. The wind industry is also moving towards larger wind turbines. The median of wind turbine production has shifted over time from 1.2 megawatt to 2.3 megawatt and now to 3.5 megawatt turbines. What is the advantage of larger turbines? The answer is, having larger turbines is much more advantageous than having several smaller turbines. Although sometimes it can be difficult to install them and commission them, particularly in hilly locations, and transporting them through winding roads or dusty tracks. However, the first advantage is that these large wind turbines intercept wind at a higher altitude. We have to remember that wind quality improves as we move further up from the ground level. See the earth boundary layer for more details. Larger wind turbines also have a better return on investment and can provide much more energy for the same footprint. And this brings us to the next question: why don't the large turbines rotate fast? The answer is that modern wind turbines, unlike their counterparts from the past, are designed to rotate slow. The slow speeds lengthen the life of the blades, which face constant shear force from wind. Similarly, gearboxes also face wear and tear due to constant rotation. One has to remember that these turbines are rotating 24/7. They may look to rotate slow, but the linear velocity at the tips can reach very high. Large-scale wind turbines can spin at 15 to 18 RPM. There's also something called the tip speed ratio, which we will come to shortly, and it also dictates the turbine RPM. Why turbines have 3 blades? Increasing the number of blades increases the efficiency. 2 blades are better than 1, and likewise 3 blades are better than 2. Also, the dynamic loading is much better with 3 blades, which helps the turbine to rotate about its vertical axis quicker. So the next logical question is, why not 4 blades or 5 blades or even more? The answer is that the relative increase in efficiency with the increasing number of blades keeps dropping following the law of diminishing returns. So while a 4th blade may add a bit of efficiency, it just doesn't justify the added cost, and not to mention the added weight increase on the hub and nacelle. In the olden days, you may have seen turbines on ranch with large number of blades. It makes more economical sense to add blades on a small turbine. However, even on a small turbine, we just can't keep on adding blades for increasing efficiency. And the answer for this lies in the Betz limit. So what is the Betz limit? In wind energy physics, there is a limit called the Betz turbine limit. Wind cannot impart all of its energy to the blades. At most, it would impart 59.3% of the total energy it carries. This number of 59.3% is the Betz limit. Adding too many blades makes the wind see the turbine as an obstacle or a wall. This makes it more convenient for the wind to sidestep or bypass the turbine rather than going through it. And it's not just too many blades that make the wind see the turbine as a wall or an obstacle. Even if very few blades are spinning at a very fast speed, the wind will still see them as a wall. And this brings us to the question, how fast a defined number of blades should be moving to gain the maximum energy out of wind and to allow the wind to still pass through them. To learn this, we have to introduce a new factor called the tip speed ratio. So what is tip speed ratio or TSR? Tip speed ratio is simply the linear velocity of a wind turbine at the tip divided by the wind speed. For different number of blades of turbine, different tip speed have been specified for maximum energy extraction. For example, tip speeds of 6 have been reported to be optimum for a 2-bladed turbine, while tip speed ratios of 5 have been deemed optimum for 3-bladed turbine. For example, suppose we have a 3-bladed turbine. Assume the speed of the wind to be 10 meters per second. We should design the turbine such that its blade velocity at the tip do not exceed 50 meters per second. This is based on a tip speed ratio of 5. A chart is shown here for reference. Through the curves on the chart, you can identify the optimal tip speed ratios of various types of turbines. How are wind turbines positioned in a wind farm? It is very important that wind turbines are not located in each other's wake, or in other words, one wind turbine should not be located in the wind shadow of another turbine, particularly in the direction of prevalent wind. Ideally, wind turbines should be at least 3 to 5 blade diameter lengths away from each other. This alleviates the influence of one turbine over the other. It should be noted that as wind goes past the blades, its turbulence increases. This turbulent wind, if it hits the other turbine, can cause a lot of vibration. Installing a wind turbine further away from an upstream turbine irons out some of the turbulence in the air. Often, available land for wind farm is limited, and so in a wind farm, wind turbines can be installed in a staggered arrangement or an O-shaped configuration to avoid turbulent wakes. This picture shows the influence of upstream wind turbines over the downstream wind turbines. Lastly, what is the capacity factor? Well, the capacity factor is a number that gives us an idea of the productivity of any power plant, not just wind farms. In short, it is the ratio of average power produced by a power plant divided by the peak power capacity of the power plant. It has to be remembered that no power plant runs constantly at its peak capacity. In fact, even coal-fired power plants face downtime because of maintenance. Wind turbines rotate at different speeds throughout the year. At times, the blades even come to a standstill, and therefore wind turbines produces a fraction of power over the year compared to the power it would have produced if it were running at peak capacity for the whole year. Normally, a capacity factor of 25% is considered healthy for a site. And this concludes the video on wind turbines.